Hello, this is Graham Knott from the EPFL in Lausanne, and in this video I'm going to show you how to use the NeuroMorph tools that operate in the Blender software for making measurements of meshes that are reconstructions of features that we've imaged with 3D electron microscopy. And here you see in the 3D window a dendrite from a neuron, and you can see along the shaft of the dendrite these protrusions or dendritic spines that are features that make synaptic connections. And in our analysis of the brain, we may want to understand the volume, the surface area, and the length of features like this. Now, this model has been derived using the elastic software that allows us to make this reconstruction in a semi-automated way. But we can also make this manually using software, for example, like the TrackEM2 software that operates in Fiji. So the NeuroMorph tools allow us to make these morphometric measurements, but it also allows us to check how accurately this model is a reflection of the structure that we've imaged. And we can see this electron microscopy image at the correct position within the model. And using these tools, we can actually scroll through these images and see how well this model is represented from these images. Okay, so let's make a start, and first of all I'll show you how to load these tools into the Blender software. Okay, so I've started up my Blender software, and here I'm using version 2.7. And the first thing to do is to go onto the File menu and select User Preferences. And then at the top of this window you'll see various tabs. So if you select the Add-ons tab, and at the bottom of that you have the option of Installing from File. And here I'll find the NeuroMorph files that I downloaded, and you'll see there are three of them. There's NeuroMorph Measurements, NeuroMorph Import, and NeuroMorph Image Mesh. And I will select each of these and install it. And the last one, NeuroMorph Measurements here, install that. And then here on the left-hand side in the categories, you can select the User button, and then you see the three scripts that you can then select and then save user settings. If I click on that, I can then close that window. Then the three tools are now installed. Now the first one is the Import tool, which you'll see under the Properties window in this Scene Context button. If you click on that, at the bottom you'll find the Import Objects tool, and you'll see various parameters that we can select for that. The other two tools are on the left-hand side in the 3D viewing window. If you just click on this plus at the top there, or select the T key, you can see these tools. Now I'll just collapse these down, transform, edit, history. And first of all, we'll see a measurement tool. I'll just move that up. And then below the measurement tool, we've also got image stack interactions, which is our third tool. Okay, so we have the three tools now installed. We have the Import Objects tool, we have the measurement tool, and also we have the image stack interactions tool. Now the next thing to do is show you how to import the objects that we've made from our various reconstruction softwares. Okay, so now I will import a mesh object into Blender. And if we look at the Import Objects tool, we have a number of options. First of all, we have the Use Remesh function. So this will add the remesh modifier. And this essentially reduces the number of vertices in our mesh. You can finalize this remesh. In other words, you can then make this remesh permanent on import. And it's probably not a good idea to use this if you're only importing a few objects, because you want to perhaps check how the shape of the mesh has changed by using this remesh modifier. There's also a smooth shading option. There is an import octree depth option, and this determines how many vertices essentially you'll have in your imported object. I'll show you that in a little while. And there's also the scale option, which is essentially the microns per pixel. Now, if you've used software in which the size of the mesh has already been determined, then you will leave it on the default function of 1. But if you've used something like Elastic, which doesn't essentially care how big each pixel really is, then you need to put in the size of each pixel. Now, the objects that I'm going to import have been made in Elastic from images which were 300 pixels by 300 pixels, and those 300 pixels were essentially 3.5 microns. So the size of each pixel is 3.5 divided by 300, which is 0.01166. So that's the number of microns per pixel. I will then press return, click on the import, and then I will find the object. So I find my object in my directories, which is this dendrite here. I then click on import, and it's going to take a few seconds to apply these parameters and then import the object into Blender. Okay, so I can see the same dendrite that I showed you just a little while earlier, this piece of dendrite with the dendritic spines. And if I now look in my modifier, I can see the options of this remesh modifier. I can see the option depth of 7. If I just reduce this value here, you can see how the mesh simplifies. Okay, and obviously the shape changes a little. And we can see that really with an octree depth of 7, I seem to get a very accurate representation of my dendrite and spine. So I'll apply this remesh modifier. Okay, so now I've imported an object into Blender, and I'll show you how to make some measurements of it. So now we will start making some measurements of this object, and you'll notice that I've in fact opened the neurites.blend file, which is the sample file that we supply. And in it you'll notice that there are a number of objects that have been imported. There are 2 dendrites, there are some synapses with this strange nomenclature here that I'll explain later, and also there are some axons. And what we can look at first in the measurement tool is that we can rename our objects with this function here, object name. I can select this option other and then simply type another name here. I could call this, for example, dendrite 5, and then update object name, and you can see in the outliner that the dendrite is now called dendrite 5. Now this renaming is important for making sure our data is in the right order at the end. Okay, so I'll just change that dendrite name back to dendrite 1. And I will show you how to measure one of the features here on this dendrite. So I'm interested to know what the surface area and volume of this dendritic spine is. So if I go to the edit option, I can now see all my vertices that make up this object. I can then select just the vertices that represent this spine. You'll notice here that I have this option here deselected, so I select all the vertices, the one in the foreground and the ones behind as well. I can then select the name that I'm going to call this spine. This is the first spine that I'm going to reconstruct on this dendrite. So it's the spine 1. It's complete in this volume, it's not incomplete. This is important for the final data output because I need to know in my numbers if this is a whole spine or a partial spine. And then I can select either surface area, volume, or both. And here I'm going to select both. And after a few seconds, calculation is made. If I then go back to object mode, you'll notice that in the outliner, in this dendrite 1, I can see 2 more objects. There's a spine 01 surface and spine 01 volume, which I can then make visible. And here are my new objects giving me a surface area and volume. And if I then go to these context buttons and select on object, I can then go down and see this object has a name of spine 01 volume. Here is its volume, this is its surface area. If I go to the surface object, it then has a surface area, and it doesn't have a volume, obviously, because it's an open mesh at the end. Okay, so this surface object, okay, has an open end where it's been cut, so it's giving me the surface for this region here, but obviously not the cut end, so be careful with that. Okay, so now I'm going to show you how to make some length measurements on this object. I'll just hide the surface and volume object that we made and re-show this dendrite. And for example, we might want to make a measurement of the length of this dendrite. What I can do is I then go into edit mode, where I can see my vertices, and I can select the vertices at one end, and then in the measurement tool, in the length option, I can add that point. I can then select another vertices at the other end, and then add that point, and then have two options. I can then do a multi-segment distance or shortest distance. Now, if I select the first one, it will simply draw a line between those 2 points and measure its length. And the second one, the shortest distance, it will make a measurement across the surface of the mesh, joining up all the points and giving me a value for that. So if I select the first one, the multi-segment distance, I see that in dendrite 1, I have a new object here, which I can show you. I'll just hide the, just go into object mode and hide the dendrite. I can see this straight line. And here we have, if we then select it, okay, you can see the length, so it's 3.068 microns. That looks roughly correct. If I then show the dendrite again, I can go back to my measurements and go back into this option. I can actually select shortest distance now. And the shortest distance value between the 2 points is shown here. And you'll notice that this line has been drawn across the surface of the mesh. I'll just then hide the dendrite again. I have this curve, and again I have the length of the curve, which is 3.2 microns. So I notice that there's a slight difference, obviously, between the length of these lines drawn, and obviously we have to pay attention if we're making an estimate of the length of an object and which actual function that we use. So once we've made all our measurements and renamed everything correctly, we have two options for exporting the data. There is one option here which is exporting all the measurements. So this gives us a data file with all the names and all the measurements associated with all the objects. And the second one is export selected. So it may be that you have a Blender file with many, many objects, but you simply only want the measurements from a select few. And there you can highlight and select a few of the objects, click on export selected, and obviously only those ones, those bits of data will be given in the file. So the image stack interactions tool allows you to see the serial images from which the reconstruction was made and allows you to check the accuracy of the model against the feature that was imaged. So you'll notice that the first details of this tool are the image stack dimensions. And this is, we need to know how large the images were. In this case, it's 3.5 microns in the X, 3.5 microns in the Y, and the stack of images is 2 microns high. The next thing is where the images are. So this is the source. So this selects out the stack of images that we supply. And then we may want to check the image against a particular feature. So if we then get into the edit mode, and I may want to see, for example, the images that make up this dendritic spine, I'll select a vertices, and then on this button here it says show image at this vertex. So if I click on that button, immediately we can see the image, and I can then select that image by right-clicking on it, and then click on the scroll through image stack, and then simply with the middle mouse button just scroll through all the images, and we can see how the features in the images change and how this feature appears at the different image slices. Of course, it's helpful perhaps to have this object transparent, so we can add a transparency with this function here, and we can also change the alpha value to make it more or less transparent. And again, we can scroll through the images and see how this dendrite changes with the different Z values. So another feature in this image interactions tool is that, as well as giving us the opportunity to identify objects by looking at the individual images and scrolling through a stack of images, we also have the opportunity to use this stack of images to find objects that may or may not have been reconstructed. So, for example, in this plane here, I have my reconstructed dendrite, and I can see where it is on the image. But I also have a feature here, which is a dendrite, and I may want to know if that's actually been reconstructed or not. And rather than going through a whole list of perhaps hundreds of objects in my outliner, and then showing them and hiding them to find this particular object, I can actually go to this feature here called Retrieve Object from Image, and then I can click on this button here, which is Display Grid, which will display a grid on top of my image plane. I can then select one of the vertices in this possible reconstructed object, and then I can go to Display Object at Selected Vertex, and if there's an object that exists, it will appear. And you'll see here immediately an object appeared. I can then right-click on it, and it is in fact indeed dendrite 2. So this tool is a means of being able to very rapidly search through a series of reconstructed objects and quickly find them and see how they relate to each other in the volume.